So means Fleming's right hand rule, but you can make it, take first 3 fingers, thumb, pointing finger and middle finger, arrange those 3 are perpendicular to each other, and then that time your pointing finger shows the direction of the field, and your middle finger shows the direction of a current, and then thumb indicates the direction of the force. Okay, and then we'll see the construction of the DC machines. Remember, for DC generator as well as a DC motor, construction remains the same. Okay, we'll see what and all it has roughly. Okay, it consists of first yoke. Okay, it consists of a first yoke, what we call this outer part. Okay, and then it is a circle, okay, round, and then we'll be having number of poles. It is like this. Okay, these are all poles. In that poles again we have a type, means we have a parts. This part is called as pole core, and this whatever base is called as pole shoes. Okay, these are connected like this. Okay, so these are your poles, yoke and poles. Okay, and then comes armature inside that. Okay, armature will be inside that, right? So remember. Okay, so this armatures, so whatever you can observe here, these are all the slots of a armature to insert conductors. Okay, right? So and then inside that there will be a commutator. This is the part. Okay, this is the important part. Okay, so which difference your in the construction, alright, of your AC machine and DC machines. If you have shown this commutator, then this is a DC machine. If you have not shown this commutator, then it is a AC machine. Okay, this is the commutator. Upon that commutator there will be brushes. Okay, and inside that this commutator will be mounted on, you can say it is mounted on a shaft. Okay, whatever it is, blue color, it is a shaft, and then this is your base. Okay, I hope roughly we have seen the parts of this. These are poles. Okay, these are armature, right? And these are slots of armatures. This is a commutator, and then blue color is a shaft, and this part whatever we have shown is a brushes. In that pole core and pole shoes, and this part is yoke. Okay, so let's see how it will be. All right, I hope now you are it is clear to you all. This is the frame, or you can say yoke or a frame, right? Field winding, I forgot to show you. On that pole itself you are going to do the windings. Okay, these are all field windings. Okay, so on the armature again, whatever the winding you are putting, those are all armature winding. Okay, and the black color is of a shaft. Okay, so then field winding which we have shown on the poles. All right, pole shoes, these are pole shoes, and commutator. Okay, and armature conductors. All right, yellow color part is the armature conductor, and then entire yellow color is your armature. Okay, so in detail we'll see its parts. Okay, so as we have seen, this is your yoke. Okay, interpole axis, which all we are not going to explain in detail about all these things, but main parts of a DC machines we are going to discuss. Okay, field winding, commutator. Okay, so you can observe all these things. Okay, so now armature tooth. Alright, armature tooth, brushes, and these are all bases. Okay, we'll see one by one all these parts. Okay, we'll discuss first yoke. Okay, first one is yoke. Remember, yoke, it serves the purpose of a outermost cover of a DC machine, okay, so that the insulating materials get protected from harmful atmospheric elements like moistures, dust, and various gases like SO2 and even acidic fumes also, okay, and so on, right. It provides a mechanical support to the poles. These are all functions what I am speaking, okay. So it provides the mechanical support to the poles, and it forms a part of the magnetic circuit also, right. So now, and this yoke is made up of what then? This, it is prepared, or it is made up of cast iron, okay, because it is cheapest, as well as it provides a low reluctance path for this, okay. And next we'll discuss poles. We'll take a pole in detail of this one, okay. So as we have said, this is your pole core and pole shoes. As we have known, it is a yoke, all right. So now, what are these functions of a pole? Pole core basically carries a field winding which is necessary to produce the flux. On this there will be field winding, okay. So it produces flux, okay. The directs the flux produces through the air gap to armature core to the next pole. And remember, this pole shoes the if enlarges the area of armature core or to come across the flux which is necessary to produce larger induced EMF. To achieve this, pole shoe has been given a particular shape, okay. So and then what is it made up of? This pole is made up of magnetic material like a cast iron or cast steel, okay. And this is about a pole, okay. And then we'll see the field windings on this. Whatever winding we are going to use, those windings, its function is carry current. Those are all carries the current, due to which pole core on which the field winding is placed behaves as an electromagnet, producing necessary flux. Since it is carrying a current, so it has to be made up of aluminum or copper, okay. And then this field winding is divided into various coils called field coils. These are connected in series with each other and wound. See, observe, another pole if you have, that has to be connected like this, and then if another pole, then it has to be in series pole, and then a starting point has to be connected here, okay. So those are all connected in series, okay. These are connected in series with each other and wound in such a direction around pole cores such that alternate N and S poles are formed, okay. The total number of poles is denoted by P, okay. So poles are noted by P, okay. And next we'll see the armature now, okay. This is the armature. You can observe armature over here, okay. This part is of armature, okay. That part is the armature. In that also, again we are going to bifurcate those two parts, like armature core and armature winding, okay. Armature core is a cylindrical in shape, mounted on the shaft, okay. It consists of a slots on its periphery and the air ducts to permit, these are all air ducts, okay. These are all air ducts to permit the air flow through armature, which serves the cooling purpose, okay. Then what is the function of this armature core? It provides a house for the armature winding, that is or you can say armature conductors, okay, where you can place the conductors here, okay. Don't see 2D, you have to observe this as in 3D, means imagine 3D. You are going to insert the conductors on this, okay. And how it is made up of? It is made up of magnetic material like a cast iron and a cast steel, okay. It is made up of laminated construction to keep eddy current losses low as possible, okay. We have seen this one in transformer as well, okay. Observe, these are all your slots, okay, where you can place the conductors. Okay, these are all our air ducts and these are called tooths. This is a shaft. Armature will be mounted on the shaft. Okay, and next thing we'll see the your commutator. As we have seen, as we have said, this is the commutator part. Okay, so this differs the AC machine and DC machine of yours. Okay, if commutator is there, that is a DC machine. If commutator is not there, then that is a AC machine. Okay, we'll see its function. It is to facilitate the collection of a current from the armature conductor. Okay, to convert internally developed alternating EMF to unidirectional EMF, which converts AC to DC. Remember, whatever it is going to generate, it will be in the form of AC only. Okay, that's what we said. If you have a commutator, then it is a DC machine. If you not have a commutator, then it is a AC machine. Okay, generating will be AC. Then commutator does the purpose that which converts AC to DC. Okay, and then how it is made up of? It is made up of wedge shaped segments of a hard drawn high conductivity copper. Okay, so these segments are insulated from each other by a very thin layer of a mica. Okay, and then we'll see we have bearings as well. We have not shown in this figure, but we have bearings. Okay, and bearings or ball bearings are usually used as they are more reliable for heavy duty machines. Okay, roller bearings are preferred much. Okay, and then we have brushes. Sorry, I forgot to explain this. These are all your brushes. So these brushes are stationary and resting on the surface of the commutator. Okay, what is the function of it? It is to collect current from the commutator and make it available to the stationary external circuits. Okay, so since to avoid wear and tear of a commutator, the brushes are made up of a soft material like carbon. Okay, this is about the total construction. Okay, I hope you have got this. Thank you.